So in this video, I'll go over introduction to exponents. So this is one topic that typically students in their early math education are going to run into, and you definitely should understand exponents and what they do and why do we use them. We typically will use these exponents for convenience to try to express certain things in terms of mathematical numbers, and later on with expressions and even in equations and various other formats like functions. But for an introduction to exponents, what I'm going to go over is I'll go over first, we'll just concentrate on integer exponents. So I'll just kind of recall integer for you. Then we will jump into kind of positive exponents, negative exponent, the zero exponent, so what happens in that case, and then we'll try to apply exponents to some negative numbers. And sometimes we have to put negative numbers in brackets to actually allow us to do what we want with the exponent. Okay, so let's get to it. Okay, so first off, integer exponents. Okay, so what are these integers? So you may recall, okay, in terms of integers that you've studied in the past. So an integer is nothing else but simply a number, and I'm going to put these two double dots equals, and I'm going to put them in a set, so in braces, and integer are the following numbers. So it includes both positive and negative numbers, but they are whole numbers, and it also includes the number 0. So you will have the number 0 is an integer, so it includes all your positive numbers, so 1, 2, 3, 4, 5, 6, and so on. So it goes on forever, except it goes up by 1. And then it also includes all your negative numbers, so -1, -2, okay, and so on. It continues on forever in the negative direction. So those are your integer numbers. So this does not include decimal numbers. It doesn't include any fractions per se, which would be rational numbers. So these are just integers. Okay, so that's the first thing that we want to be able to know. Now, what is this concept of an exponent and where does it come from? So this concept basically comes from some kind of multiplication, and when the multiplication becomes repetitive, so when there's multiple repetitions. So for instance, many students will know that, for instance, if we take 2 and we multiply it by 2, the answer is 4. And of course I can continue this pattern and I can say 2 multiplied by 2 and then multiplied by 2 again. Okay, so don't get caught. It's not 6 because 2 times 2 is 4 and then times 2 is 8. And again, so we can continue this pattern, and I am just using the 2's, but they're repeating. So this would be 16. Now you can imagine as we get to more and more of these multiplications, it actually becomes a little bit annoying to try to write all of this out. And eventually, you know, imagine if we had 10 of these multiplications or maybe 20. You know, you may wonder, am I going to really need that? Well, yes, in sciences and in business and many other applications, you eventually will if you continue studying and going on through your education. So exponents do go up, and they go up to very big numbers. But you certainly wouldn't want to be writing 2 times 2 20 times. So there must be some better way of representing this. And this is where exponents really come into play. So we can continue this pattern with these, but instead what we have introduced is we have introduced the concept of an exponent. So instead of, for instance, writing 2 times 2, because you're just repetitively multiplying 2, well, instead you can take your 2, which you are multiplying, and then you're multiplying it 2 times, and we create this little exponent. And that particular exponent basically now tells us how many times is 2 being multiplied. Now in the second So just below it, notice that we are multiplying 2, but we're doing it 3 times, and that's the exponent now becomes a 3. And you can continue with this pattern, and of course the next one would be 4. So what we typically say is we will take any exponent that we have, and you can apply it to any number. Now, the number 2 I just chose arbitrarily, but it could have been 3 times 3, it could have been 10 times 10 times 10. It doesn't really matter what it is. So whenever we're running into these exponents, and you can pick any numbers that you like. So we started off with 2, and let's say, if you wrote the exponent 20, it means you would have to multiply it 20 times. I mean, have fun trying to write that out, but that's what it would mean. Now, again, you can write it and apply it to many different numbers. Let's say 10, and then say 10 to the power of 5. And you can apply it to many others. Now, can you apply it to decimals? Yes. Now, when I talked about integers, I was referring integers as being the exponent itself. So for now, we're just having positive exponents. So if you have, for example, 3.5, you can certainly put this to the exponent of 3, and what it would mean is you would have 3.5 multiplied by itself 3 times. Like I would draw it out this way. So that's what exponents are used for. They're actually pretty convenient in terms of math applications and any applications in terms of sciences or business or engineering or something like that in the future. So we use these exponents for convenience. It's a much more compact way of trying to replicate something which is multiplying by itself numerous times. Now, there is something to know. So if you do write this out, so for instance, when we wrote 2 to the power of 4, there is some terminology that you probably should know. So you know that this means an exponent. Exponent. This right here, okay, the number that is actually repeating, we call that the base. And if you wanted to basically say this out in full, you would say 2 to the power of 4. Now you can say 2 to the exponent of 4 as well, but very commonly this would just simply be stated as 2 to the power of 4. So that's what we would actually say. And you can write any number that you like, of course. So any base can happen. So this base right here, it can be any number that you please. It depends, of course, on the application that you are using. And that is kind of the introductory component of this concept of exponents. So exponents are just a convenient way of representing multiplication of the same thing numerous times. That's what an exponent is. So now in our next topic, so if I scroll back up here, so notice I said we would cover that we're only talking about integer exponents. So I introduced that. So we have now introduced kind of positive exponents on any number that you like. So you can have a positive exponent. So notice all of these were all positive. So these were all positive integers. So right here, so all of these are positive integers. So that's what we had there. Now, what happens if you actually have negative exponents? Can that happen? Because notice integers right here. So what we have, okay, so we talked about the positive ones, but you also have negative. So if I wrote something of this nature, okay, so if I write this particular example, so I have, for instance, still 2, but what if now I said to the negative 2? What does that mean? Right? So what actually happens there? Well, so this is interesting. Okay, so there's basically 2 ways of looking at negative exponents. So here, what we had, okay, we said that we were multiplying, right? When these exponents were all positive, so it was 2 times 2 and 2 times 2 times 2, which was 2 to the 3. and so on. So that's what that would mean. Now, a much easier way of thinking about negative exponents, instead of multiplication, you can think about dividing. So what does that mean? So what this means, okay, so this right here, it means you are actually now dividing by 2, okay, and you're dividing 2 times. So that's what this would mean. Now, in contrast, when we were doing multiplication, so this was 2 to the power of 2, so this means 2 multiplied by 2, 2 times. Now, in here, you might say, well, what are you dividing, right? Okay, so here you are multiplying the 2 by 2, so you're just multiplying the same numbers. But here, what am I actually dividing when I have these negative exponents? If there is no number in front of it that you have, okay, so what this actually means, you're just simply dividing by, okay? So you have a 1 there. So it's dividing the 1 by 2. So I can actually represent this when you're writing this out. So this really means, again, if you think back of kind of your fractions, so this really means the following. It is divided by, okay, 2, and this happened to be division by 2 times. Now don't get fooled because you say, oh, but you're putting multiplication here, okay, so what's going on? Don't forget that you are actually dividing this. So this means exactly 1 divided by, okay, 2 times. So you're dividing it by 2 times. Okay, so in this case. So both of these are equivalent. Okay, so they're exactly the same. So negative exponents actually means division. That's what it actually means. So if you were writing something of this nature, so let's take a different number, let's say 10 to the negative 4. So what does that mean? Well, this, okay, actually means you're going to divide by 10 4 times. So you can write it in this way. You can divide by 10. So once, twice, 3 times, 4 times. Or you can write it, this means exactly the same thing as just simply saying 1 divided by 10 times 10 times 10 times 10. So notice in both cases, it is 4 times. So these two right here mean exactly the same thing. That's what negative actual exponents mean. So they do have a meaning. And the meaning means we're going to be dividing by that number as many times as we want. And you can write it in 2 different formats. All right, and that's what I have just highlighted here for you. Okay, so you can either highlight it, sorry, you can either do it this way, or, okay, you can write it out like this. Okay, so that's what that would be. So both of those actually work. So those are negative exponents, and that's what you have there. Now, the next item that we had, what would happen if we now had 0 exponent? What does that mean, 0 exponent? So this is common, and sometimes always somebody raises their hand right away, and they may remember from some point of view what these 0 exponents actually mean. So before I introduce this concept of a 0 exponent, 0 exponent, all right. So what I will make you kind of think about, okay, in terms of these 0 exponents, okay, and let's say, so we're going to use the base 10, okay, so the base, okay, will be 10. Now, the base could be anything. It could be 2, it could be 3, it could be 3.5 or something like that. So now, my question is, okay, so what is a number that is raised to the power of 0? So that's my exponent is 0. Now, in short, the answer actually is 1. That's what that means, guys. And you may say, that's strange. Why is it 1? Okay, and now this actually is true for any number. So if I said 2 to the 0, this also means 1. Now, if I even wrote a negative number, so let's say negative 3 to the 0, okay, with this one, we have to be a little bit careful. Okay, so I'm going to put a question mark here for the time being, and we'll come back to it when we actually have some negative numbers and exponents applied to that. But in general, okay, so what happens here is if you have a positive number, so you have a positive number and it is raised to some integer, so to some exponent. Okay, so I'm going to put a little n there. So this is some exponent. The answer, okay, and that particular exponent is actually 0. So let me write in here. So in this case, if it would be 0, then the answer would be 1. So that's what we would have. All right, how does this happen? Why does it happen? I mean, do you care? Well, I hope you care, at least a little bit. So now let me ask you something. Okay, so let's say I'm going to take that base 10 and I would have 10 to the 1. What is 10 to the 1? Well, 10 to the 1 is just 10 because you're multiplying 10 one time. Now, what if I asked you, okay, what is 10 to the minus 1? Well, from what we just did, you would say, well, this is, you're dividing by 10, okay, one time. So we basically are dividing by 10, or we can just simply write division in this way. Okay? So that's what we have there. So that's interesting. Okay, so let me move a little further. What if now I took, okay, so this 10 right here, okay, and then this right here. So what would happen if you took 10 and you divided it by 10? Well, if I take 10 and I divide by 10, my answer is going to be 1, because 10 divided by 10 is 1. And I could have done this with anything, right? I could have said 2 divided by 2. You wouldn't really argue that it is still 1. And that brings about this component of 0. Okay? So exponent of 0. So what we have, okay, is if you have 10 to the power of 1, now if I subtract 1, correct, 1 minus 1, then this gives me 10 to the 0. And what I just said above, right here, so 10 to the 1, okay, is just 10. And so the minus 1, so 10 to the minus 1, is dividing by 10. So what I'm doing is I actually have 10 divided by 10. So this 10 right here, that comes right there. And this division, well, that's division. So notice 10 divided by 10 will be equal to 1. And as you know, and as you can see, okay, so the exponents, 1 minus 1 is 0. So indeed, this would be equal to 1. And you can do this with any number. We could have said 2, 1 minus 1. So this really means 2 divided by 2, which is equal to 1. But hey, wait a minute. 1 minus 1, then the exponent is just 2 to the 0. And notice that it equals to 1. And that is the reason why we have actually any number that you have, so any positive number that you will take, and you will raise it to the exponent of 0, it's going to be 1. So if I asked you some huge number and said this to the 0, it is equal to 1. Because this just means 329 divided by 329. And it is equal to 1. So that's what we have there. So now we have positive exponents. We have negative exponents. What those mean. So positive means you're multiplying. Negative means you're actually dividing. And 0, okay, well, it just means you get a result of 1. There's really nothing else to do. So the last component that I wanted to do in this introduction is what happens when you start applying these exponents onto negative numbers. So what happens if you start applying these exponents onto negative numbers? So what happens and how should you think about this? So you have to be careful here. And this is what I'm going to just write out for you. You should know, and again, I'll take an arbitrary base, so let's say 5. Okay? So if I said 5 to the 3, you know that this means 5 multiplied by 5 multiplied by 5. Now, versus, okay, so what if I compared it, and now I would say, what if you had negative 5 to the 3? You say, well, that's easy, or at least you should kind of intuitively start thinking and connecting the dots. And this should just simply tell you that, well, this is negative 5 multiplied by negative 5 and multiplied by negative 5. And we can get our answer. Now, it turns out that, if you did 5 times 5, which is 25, times 5 is actually 125. If we did this right here, you would get negative 5 times negative 5. Now, don't forget, negative and negative becomes a positive. So this is 25. And 25 times negative 5, so now it becomes negative 125. But, and this is always the trouble that students run into, what I wanted to mention in this video is to make you aware that if you don't have those brackets around your negative number, you have to be careful that it may mean actually something else. So when you have an exponent, so if we have an exponent right here, this exponent actually always applies to the number that it is attached to. So when you do not put a negative bracket, as we did in this case, so right here, so we had a negative bracket. Notice on the negative 5 to the 3, so this last one right here, I did not put any bracket whatsoever. So when that happens, this negative 3 actually only applies to the 5 directly. And then the negative will just stay in front. So what that would mean is you would have a negative, and then you have 5 to the power of 3. So this would mean 5 times 5 times 5. And now we already know what this is. This is 125. And so that negative, okay, so will still stay in front. And you will say, well, that's not really any different than from what we did right here. We still get the same answer. So be careful, because when the exponent is actually an odd number, and 3 is odd, right? 5 is odd, 7 and 9. Then these two will actually be equal. But what if I changed it? So notice, if I did something like this, and I changed this to 2, which is now even. So now the question is, what if I had this? Will they still be the same? Well, if you work it out, notice that this means -5 multiplied by -5, which is 25, because negative times a negative is positive. But in the other case, this means -5 times 5, and look what happens. This is negative. So, be careful. They are not the same. And I wanted to mention that in this introduction for these exponents so that you kind of have an idea. And you can try these exponents and try to play around with them and rewatch the video, make your own notes to try to see if you understand the concept. So basically, you should now know what happens, okay, to 0, okay, so exponents of 0. And you should know what happens and what the meaning is of positive exponents that are integers in this case, or negative exponents that are also integers. Before I let you go, okay, and you finish with this video, so here is something of interest, hopefully to you. If you put this and you put it to the 0, does it equal, without the bracket, to the 0? So based on what we just talked about with the brackets and applying them to negative numbers, are these the same? So this is actually equal to 1, because if you take any number and this number is in brackets and you raise it to the power of 0, the answer is 1, as we had shown, and you can rewind the video there. But here, this 0 only applies to the 3. So here, be careful. 3 to the 0 is 1, but this negative will stay in front. So whenever you have negative numbers and you really want to put an exponent on them, you have to put them in brackets. If you do not, then that particular bracket, I apologize, that particular negative is not part, and it doesn't take any part in actual exponent. It will just stay there as it is in front. All right, so this is an introduction to your exponents. I do hope that you find this useful. All right, so thank you for watching.